One student from the University of Cincinnati is helping NASA do important work when it comes to looking for life on Mars. We talked to him about the work he's doing and what he hopes to find.
We have evidence of life on Earth that goes very far back in time, billions and billions of years. So what we're trying to figure out is, does this simple life exist elsewhere in our solar system? So we're looking at Mars because we can get to Mars. We've gotten landers there before, we've gotten rovers there before, and now we have the technology that we can really kind of dig deep and figure out where might we find life, what might the life look like.
You know, we had the idea for the project and we gave it to Andrew and said, hey, would you be interested in doing this as your project? And he was, and he's run with it and has developed it into, you know, what it is now, which is more than what we originally envisioned.
What we're going to be doing now is we're going to be going to Mars. The plan is to send a lander there, send a rover there. The rover will be collecting samples and then it will be bringing them back to Earth. So what we're going to be looking for is, can we find evidence of this simple microbial life that has been preserved or fossilized on Mars? This pattern here, this sort of curved structure, is called a stromatolite. And what this is believed to be is evidence of past bacterial life that was living in this rock. It's evidence, we believe, of photosynthesis, because what you're looking at here is this curved structure is the bacteria trying to move upward towards sunlight as sediment is deposited on top of them, and they keep moving further and further up to get more sunlight, perform photosynthesis. And this is 3.5 billion years old.
And this relates to what Andrew is working on, developing a chemical biosignature to detect life in rocks. Even if the life is, you know, long gone, it may have left this chemical signature behind.
So best case scenario, if this method that I'm developing is useful as a biosignature detection method, hopefully I can get one of these samples someday and actually run some analyses on them.
So this mission is really supposed to just look for fossil life, but again, if it happened to come across something that was alive, they're not going to ignore it. They might not bring it back, but they're not going to ignore it.
People are really interested in the alien aspect, that's for sure. Maybe get less excited when we're saying that we're looking for fossils of bacteria, but you know, it's still at its core gets to a base question of finding evidence of, are we alone in the universe? I haven't always been interested in Precambrian paleontology per se, but you know, space just as a general topic, I mean, I think it's almost a prerequisite in this field that you have to be a big Star Wars fan growing up and whatnot. So hope we find life, and I hope I get to work with it.
Yeah.
Wow.
That was amazing.
Isn't it?
I know. Well, you know what? Something interesting about Andrew's project is that these missions take so long. It will take 10 years for these samples to get back to Earth for him to examine. Can you imagine waiting 10 years?
That's a long wait,
a long
but you know, they're
time.
talking about maybe finding life. Wouldn't that be incredible?
That would be.